Hey folks, how's it going? This is Mr. Murray coming to you with a video on 4/7/2020 for Course 1 Honors. Alright, so what I want you to do is we're moving forward here. We're going to be solving some more equations. So again, we don't know what method we're going to use here. You need to determine the appropriate method to use, and then you need to solve the equations, keeping in mind that there could be 2, 1, or 0 solutions. I'm not going to tell you which. Use any strategy we learned so far, whether that be factoring or square roots. All right, so please pause the video, find all solutions to the 3 equations, and then when you're ready, unpause, and I'll show you how to solve. Okay. So here we go. I'm going to start with this one. So this looks like, due to the existence of a b value, we are going to want to use the factoring method for this. We don't have another way to do it. So what I'm going to do is I'm going to start by making it equal to 0 by subtracting 2k squared and 5k. So 6k squared minus 2k squared, that's 4k squared. 62k minus 5k, that would be 57k. And then the 14, nothing combines with that, and that equals 0. So let's open up our box and try to factor. Now, the challenge is going to be, so look, we know that these numbers are going to have to multiply to 14. And we know that these two multiply to 4k squared, these multiply to 14, and yet these boxes need to add to 57, right? So because they're adding to a positive and multiplying to a positive, we do know that we're looking for 2 positive numbers. But now, how do we get 57? Well, this is going to be one of the slept-on combinations. So what I think we're going to need is, this is a 4k and this is a k, and this is a 14 and this is a 1. So it's a double, like 4 and 1, 14 and 1. Okay, because let me just double check this, because I know that 4 times 4 is 16, so that when I do 14 times 4 to figure out this box, you're going to get 16, carry the 1 for 56. Perfect. So this is 56k. This is k, so they add up to 57k. So this breaks down as 4k plus 1, k plus 14. Notice that the 4 could not possibly go with the 14, because if the 4 went with the 14, then the factor would have a greatest common factor, right? So what I'm saying is, this is not a factor, because otherwise you could factor it out like this. But if this has a greatest common factor, then the whole thing should have a greatest common factor, and we know that it does not, okay? Because 57 is not divisible by 2, right? It's not divisible by 4. So that alone, because I'm thinking about the a value, makes it impossible. So my solutions are going to be, this will be -1/4, and this will be -14. All right, moving on down to the next one. Again, the existence of a b value tells me that I'm going to need to use factoring again. So I'm going to start by making it equal to 0 by minusing 8. So I've got 3r squared plus 42r plus 147 equals 0. Now, I then notice that, right, 4 plus 2 is 6. So 42, because its digits add up to a multiple of 3, is divisible by 3. And then 7 plus 1 plus 4 is 12. And so since these digits add up to a multiple of 3, 147 is also divisible by 3. So what I'm going to do is I'm going to start by, you have 2 options. You can either divide both sides by 3, but what I'm going to do is I'm going to take out the greatest common factor. So dividing 3r squared, removing the 3 gives you 3. Okay, dividing 42 by 3 gives me 14, and the r stays. And then dividing 147 by 3, let's just set up a long division. So 4 goes into 1 no times. 4 goes into 14, rather 3 goes into 14 4 times, leaving a remainder of 2. And then 3 goes into 27, nice, 9 times, and getting a remainder of 0 as we expected. So to check our work, again, distribute 3r squared plus 42r plus 147. So you can verify if you redistribute, everything works. So now what I essentially want to do is I just want to box this. Okay, so I get 49. I get r squared. And now I need these to add up to 14 and multiply to 49. So I'm looking for 7 and 7. So I get 3, r plus 7. R plus 7 is 0. So 3 times r plus 7 squared is 0. So the only way this is going to work is if r plus 7 equals 0, right? Because then you get 3 times 0 is 0. So that means r has to be negative 7. So only one solution, it's negative 7. Moving on to the last one. So here we do have an option of boxing out s minus 5 squared, turning it into standard form, simplifying and solving. That is a possibility. However, I look at it as this. Imagine that s plus 5, we called that like x. Well, what we'd essentially have is negative 2x squared plus 5 is 103, right? If x was that. And so essentially we have no b value if you think about it like that. So what I'm going to do is I'm going to solve this using square roots. Now, please remember the order, right? So I'll rewrite that. So imagine it was 2x squared, negative 2x squared plus 5 is 103. The first thing you would be doing would be subtracting the 5, right? If you were going to get x alone, you wouldn't be dividing by negative 2. So don't do that first. It's a common mistake. You don't want to make that mistake. So 103 divided by 103, rather, subtract 5. That would give me 98. Divide by negative 2. S minus 5 squared is negative 49. And then you can see when I go to take the square, at this point you can say either no real solution. And since we're using s, you could also say s is not a member of the real numbers. Or we could go ahead and try to solve this with complex numbers. So s minus 5 is equal to plus or minus. So this breaks down as 49 and negative 1. So this breaks down then as the square root of 49 times the square root of negative 1 if you want to use complex numbers. And then you'd add 5 to get s alone. Plus or minus 7i. So in this case, again, if you say no real solution because we're still in course 1 honors, 100% correct. If you say s is not a member of the real numbers, 100% correct. If you want to solve with complex numbers and say s is 5 plus or minus 7i, mathematically 100% correct, I would take that as well. So folks, hopefully you found this video to be helpful. Hopefully you were able to get all 3 correctly. Again, we'll recap. First one, factoring is the only way to do it. Get the right hand side equal to 0 and factor to get negative 1/4 and negative 14. Okay, here we notice we again can only do factoring, so we make the right 0. We remove a greatest common factor so that we get an a value of 1 when we actually have to do the box, right? And I guess what I should do is fill this in, right? We then notice it's a perfect square because 7 times 7 is 49, and then we get the two 7r's adding up. We then factor it, turn it into the square, and get one solution of negative 7. And then finally here, we need to use square roots. So we isolate the square by subtracting by 5 and dividing by negative 2. We get a negative, so that when we go to square it, we could say there's no real solutions, or it's not in the real numbers, or we could follow it along and solve with complex numbers. Please make sure if needed you rewind so that you can fully understand this. But otherwise, keep up the good work, and don't forget, you can do it. All right, thanks for watching. Have a wonderful day.